Hello, my name is Christy. It's my huge pleasure to be presenting today on behalf of PolyWavePower IP. And we're going to be presenting a rare earth-free stationary field synchronous motor technology that's being made available for strategic acquisition. PolyWavePower IP is the exclusive owner of this motor technology, which it comprises a global patent portfolio. Really looking forward to sharing information about it because it really is a global disruptor that's going to work across diverse industry verticals. If you look to the infographic on the right-hand side, you can see the sheer range of spaces that this motor technology can be applied to, which means the addressable market is extremely large. So from industry application for use in generation for power, whether it's transport, mining, marine, or aerospace, and indeed defense, this motor performs and gives a true IE5 class performance and really redefines how it is that energy can be generated across multiple sectors. The most incredible feature relating to it is, of course, that it's magnet-free and that it has a stator-excited design, which eliminates rare earth dependence. And at the same time, there are a huge number of operational benefits that include ability to enhance efficiency. It's reliable, it can be controlled. So really, whether we're talking from turbines to marine propulsion, electric vehicles, there's just a huge number of ways that this very adaptable architecture is able to power a new era of sustainable and high performance electrification. So let's talk to that delivery against the strategic need, and whether it's government or a major manufacturer, there is this urgent need for an efficient motor technology that does not use permanent magnets. And this magnet-free design enables protection of the supply chain. It reduces exposure to those price spikes, and really helps to meet security and compliance requirements. And so if we look at that story, this is a stationary field synchronous motor. It's patented across the globe, and is able to remove a major vulnerability, improving overall efficiency and performance. Modern electric motors and generators currently depend heavily on permanent magnets to operate efficiently, and most of these magnets are 90% sourced from China using rare earth metals. So countries and original equipment manufacturers across sectors depend upon this source of supply. At the moment, whether it's EVs or drones or turbines, industrial machinery, defense systems, they all need to have magnets. And these magnets are expensive, their prices are highly volatile. This increases the cost of production. In addition to this, traditional AC induction motors, which are the common workhorses of industry, also suffer from quite severe power factor loss. And this is something that the SFSM is able to address. So at the moment, if you look at motor topologies, there's a lot of wasted electrical load that is caused by reactive power oscillating inside that motor instead of producing motion. And these losses from the current induction motors strain the grid and contribute to industrial power factor penalties, which tend to be increasing globally. So alternatively, the SFSM achieves a power factor of 1 with full reactive energy recovery, which really is a remarkable achievement. So it's for sale. PolyWavePower IP is offering its patented rare earth-free synchronous motor for acquisition by an interested and capable strategic partner. Just to remind you, those core features include a global patent family, its magnet-free synchronous design, that there are no permanent magnets, slip rings, or rotor windings, and it's got this phenomenal multi-sector applicability across propulsion, UAV, EV, marine, and generation for both wind and for industrial. It's the complete IP package, including the patents, the prototypes, the engineering files, and also the design models. So those key benefits include that it eliminates rare earth dependency and reduces cost and geopolitical exposure. It improves reliability, and it has a phenomenal lifespan because it has a simplified and cool running rotor. This has a lowered manufacturing cost because it's able to use standard transformer grade tooling, and it enables sovereign NDAA compliant propulsion systems for defense as well as for industry, which provides the acquirer with full control of a strategic and next generation motor platform. So there are really three competitive advantages that we want to speak to. The SFSM motor topology offers three unique performance advantages that help it to outperform both permanent magnet synchronous motors and synchronous reluctance motors, which are the two key contenders out there in the marketplace, whilst also providing a very transformative alternative to the induction motor technology that still represents more than 90% of all motors in service. The first thing that we want to look at is its patented stator-based field coil. So this patented topology employs a stator-based field coil to excite and fully control the magnetization of the salient poles of the rotor. The rotor is therefore free of field windings and slip rings. This makes it quite low in mass. This makes it very cool running and reduces and lowers maintenance. So this is a major achievement and a major advancement over existing wound rotor or permanent magnet synchronous motors. Okay. The second key benefit is its optimized efficiency under all load conditions. And what we mean here is that it maintains a high efficiency across all operating conditions. Its inherent power factor correcting behavior strengthens the performance of the entire electrical system by reducing reactive power demand, lowering the overall grid energy cost, and increasing the usable capacity of existing electrical infrastructure. The third key benefit is that it also eliminates complex high-power electronics. So advanced high-power converters are not required to line start or to run the SFSM motor at grid synchronous speed. So it's got minimal low power electronics to manage the DC, and it uses only a small fraction of the motor's rating. So this simplifies manufacturing. It means that off-the-shelf variable speed drives can be combined with the patented two-phase square wave drive. Really, this helps to provide redundancy and ripple-free torque that is comparable with premium machines. So we get a very high performance without those complex power electronics. Let's take a little bit of a closer look at this simplified sort of stationary field stator topology, because it's lightweight. It's got pre-assembled components which enable rapid robotic or manual assembly with time savings up to 30% on the production line. So while the outer positioned armature coils enhance its cooling efficiency, and the stator-based induction rings provide a straightforward, reliable starting mechanism without the complexity of rotor-mounted cages. Okay, so we're talking overall here reduced assembly time, we're talking efficient cooling, and we're talking about very simple induction rings. So the PWP has got a slotless stator with salient poles for the armature windings, and these are just very simple wound coils. The stator is assembled from just three components. These include laminated stator modules, built-in stator dumping starter rings, and pre-wound armature windings. So the coils are very, very easy to wind. It's very simple and unspecialized standard machines that are able to make this motor design, saving resource, time, cost, only the copper bobbin needs rewinding with no derating needed. So if we look at our diagram, you can see the slotless stator on the left-hand side, and you can see the three typical kinds of winding that get used. And this is orthocyclic winding, which is best. Both the damper rings and the windings make use of this high-density winding for the most efficient copper packing, which offers extensive production line efficiencies. So a very simple and very easy motor to be working with. That performs. So what is exciting to point out is that this is giving a verified synchronous performance. We have got test results that can be made available that are from the Department of Engineering at the University of Cape Town. And they demonstrate that the SFSM is able to maintain efficiency across all load conditions. So if we look at the chart on the left, we can see how the motor's armature current changes as the field current is adjusted at different load levels. So this demonstrates that the SFSM enables field current control and power factor adjustment and reduction of current draw by tuning the stator field. So it maintains a very low current and operates close to unity power factor across a really wide range of loads. This is a standout feature because most traditional motors actually lose efficiency and power factor stability at light and at partial loads. And so the test results really show that the SFSM is delivering that strong full load performance while also achieving exceptional part loaded efficiency. Since most of the motors operate below their rated load for a lot of their operational life, this capability provides lower losses, reduced grid penalties, and really is able to give meaningful energy savings, especially when applied at scale. So this motor topology really does deliver direct benefits right the way across the value chain. If we start by looking at licensing, the traditional motor industry challenges that we face are a very fragmented IP landscape with magnet-related obligations that are creating both complexity and cost to pay. So this is a very simple single global patent family, which is able to give clean ownership with no magnet-related IP entanglements. So it's a very straightforward technology transfer that's being offered. If we look at the next stage in the process, you've got sourcing. The challenges there include a highly volatile rare earth magnet pricing, exposure, export controls, unstable bill of materials. And what's being offered here is less expensive and more stable sourcing because it's possible to use metals that are generally available locally. It's your steel, your aluminium, and your copper. You can have quite a stable bill of materials, which really means less exposure to that commodity volatility. When we step into the manufacturing part of the value chain, there are huge benefits as well. High precision rotor machining and magnet insertion is challenging. There's gluing and a lot of specialist rotor assembly challenge. And in terms of this topology, we're talking about a lower cost of production, very simple conventional processes with no magnet insertion. There's lower tooling cost. There's higher scalability and reduced rotor complexity. So overarchingly, this is an easier motor topology to manufacture. When it then comes to installation of your motor, typical challenges would be that variable speed drives are required for the permanent magnet topology or for the synchronous motor topology, which adds a lot of cost and complexity, which results in slower and more expensive commissioning. For the SFSM, there's a lower commissioning cost because of the self-start capability in field off mode. The variable speed drive is not mandatory. You get faster installation and also actually incidentally retrofit with drop-in replacement for many of the for many OEM platforms. When it comes to operating the motor, challenges can be low or fixed power factor, causing reactive power loss and penalties, efficiency drift, and grid instability. In terms of this alternative, we've got a longer, cheaper lifetime due to its adjustable power factor. When in field on, it's got very low heat. It's giving you stable IE5 level efficiency. So you're talking about reduced grid penalties and improved stability. When it comes to maintenance, magnets, permanent magnet-based topologies have a lot of heat degradation. You have to deal with demagnetization risk and complicated rewinds, which really reduce the motor's efficiency after time if they aren't done quite right. And with the SFSM, you get a lower maintenance cost due to the fact that you're not dealing with magnets degrading. You've got a robust rotor, you've got easy stator access, you've got a robust simple rotor that's got fewer failure modes. And on the stator side, field coils, it's just very accessible and service friendly. And then last but certainly not least, from a sustainability perspective, at end of life, there are challenges with magnet-based systems that require complex disposal. There's hazardous waste involved and quite poor recyclability. And this is a much more environmentally friendly solution due to being able to use pure metal recycling with no hazardous waste, and you've got opportunities around circular economy aligned ways of working with easy remanufacture and refurbishment as well. So these are a lot of key benefits right the way across that value chain. So overall, we believe that this is the best electric motor topology performer. It's quite nice to look at sort of the history of electric motors, and you can see in this infographic that there's two sides of the family. There's the AC motor family, of which the SFSM is part, and then the DC motor side. And so if we go right the way back to the original asynchronous motors that were invented, you've got Tesla's squirrel cage induction motor around about the 1880s, which was able to give around about an IE1 type performance, stretching towards an IE4 and a wound rotor induction motor. And then there is the wound field synchronous motor, which can achieve a 99% efficiency for very large models, but has extremely complex power transfer and very complex electronics as well, which leaves us really with the permanent magnet synchronous motor, the PMSM, which is in terms of the IE5 class, the incumbents, but requires these rare earth metals in order to source its permanent magnets. There's also the synchronous reluctance motor, which was invented originally in 1923 and has had a revival, sort of since the 1990s, that can achieve an IE5 class performance. However, extremely complex electronics. And so the stationary field synchronous motor on the right hand side, which has been invented between sort of 2016 and 2023, is able to give that IE5 class performance without the magnets and without the complex electronics. And if we look at the IP side of things, it really does offer a protected platform for commercial expansion. So PolyWavePower has secured a 20-year patent family with national patents that have exclusive rights running from July 2023 across global markets. So this has created a protected platform that can be leveraged for commercial expansion. The patents enable two clear routes to market. It can be exclusive licensing to regional manufacturers or a full IP sale within selected sort of territories. And the key benefit within this is that the SFSM can use locally available materials, which mean that local sourcing can become a very powerful commercial advantage. Why is this advantageous? Well, it lowers the production cost, it eliminates import duties, it reduces supply chain risks, including price volatility, and it promotes localization and job creation. So it's really meeting evolving ESG and compliance expectations and giving us an electric motor topology that is attractive to original equipment manufacturers because it enables a more profitable, risk-free operation. And what we're looking at here is really a better power factor at a lower cost. So the SFSM PWP motor sits at the very, very high end of operational efficiency, giving that power factor of 1, which wildly surpasses sort of the induction and the synchronous reluctance motor and the PMSM technology, while offering the performance of the synchronous machines at a lower cost, which makes it able to compete with the 85% induction motor replacement market quite effectively. So if you look at that chart, we're talking about a very high power factor at a very low cost. So the traditional induction motor still holds the largest market share at around about 85%. It's a low cost technology, but delivers a very poor power factor, particularly in smaller motors, which results in operational inefficiencies. So smaller markets at the moment, if you see up towards the higher capital cost and higher operational efficiency, are owned by the synchronous reluctance motor and the permanent magnet synchronous motor, which do offer a higher power factor, but are more expensive to produce. So the benefit here of the stationary field synchronous motor is that it's achieving that power factor of 1 with full reactive energy recovery at a manufacturing cost that's comparable to an induction motor and significantly lower than the other premium synchronous machines. And it's achieving this without rare earth magnets and without high power complex electronics. So let's take a little look at that competition in more detail to understand the markets that we're addressing here and do a bit of a motor topology comparison. So we've pulled together some market research and that demonstrates that at the moment the global electric motor market has been valued around about 197 sort of US dollars. This is sourced from the Grandview Research electric motor market analysis, which has got projections between 2025 and 2030. And they're projecting that the market is going to reach sort of 322 billion US dollars by around about 2030, with a compound annual growth rate of around about 8.5%, which places the markets, if you really want to extrapolate, probably if that continues, about 480 billion by 2035. And at this scale, we believe that a 3.5% SFSM market share would represent an addressable market size of circa US sort of $17 billion, which is very significant. You can see those different topologies sort of illustrated in the picture. At the moment, the permanent magnet synchronous motor is sitting there with maybe circa 10%. Which means that its value at the moment is 19, call it 20 US dollars. And the synchronous reluctance motor is really only got a penetration of around about 3%, sitting at about 5.9 in 2024. And in terms of the wound synchronous motor, 2%. And the traditional IER5, which is the one that's a good one to gun for, sitting with 85%, 168 billion in 2024. And finally, if we look at the stationary field synchronous motor, which is obviously pre-market at the moment, and we imagine that over the course of the next decade, that by 2035 it was able to acquire a 3.5% market share, which is really quite conservative, and that would be worth around about 17 billion US dollars worldwide, which is big. So let's look at that potential growth and understand, how we can possibly forecast market penetration. So what we believe is that by 2035, that the stationary field synchronous motor could credibly secure 3.5% of the global motor market, that is valued at around about 400 billion, then basically this would mean that there's a 14 billion in annual addressable motor revenue for licenses. And so we've got a chart here that shows obviously the technology would need to be going through beta engineering with prototypes and licenses through the course of the next year. We've got a set of assumptions that says that if we want to look at that market penetration curve, if we were to beta roll out to 5 licensees during to 2026, and to give a sort of a ramp-up time through the OEM integration cycle, which would typically be between 18 and 36 months, that we would be looking at the first commercial product launches around about 2028. We would then see that around about 2032, the IE5 would be like a procurement differentiator and ready for expansion into OEM platforms globally, certainly by 2035. So let's have a little look at that royalty revenue stream, and we've put together a revenue model here that looks at industrial royalty rates between 3%, 4%, and 5%. This is quite realistic a percentage royalty to build for a high performance and differentiated set of IP. We believe that given SFSM's IE5 efficiency, its magnet-free design, its lower electronic cost, that 3 to 5 range would be commercially credible. In terms of most OEM licensing deals, this would typically include an upfront license that's around about 2 to 10 million US dollars per original equipment manufacturer. Normally, there would also be an engineering pack access fee that would be billed between 1 and 3 million US dollars, as well as support and technical integration fees. If one was to have, from a royalty perspective, 5 to 8 OEMs secured the upfront licensing revenue beyond royalties, with a 3.5% market penetration, could be between 15 and 80 million once off. So then from a royalty perspective across those low, central and high scenarios, you can see what the royalty revenue fee starts to be as the market share growths. And then bottom part of the chart, we show what that looks like cumulatively. So why will the SFSM lead the motor industry? In terms of summary, the SFSM platform delivers unmatched lifetime value by eliminating rare earth risks. It simplifies manufacturing and installation, achieving an IE5 class performance and maintaining exceptionally low operating costs. It's a fully protected IP position, and it's a real acquisition opportunity that should not be missed. Why? Because of that low bill of materials with no rare earths and the feasibility of full local sourcing, because of the lowest manufacturing complexity and cost, no magnet handling, because of the lowest installation complexity. It's got this self-start capability. Because of its highest operational value, IE5 efficiency, plus power factor control. So we're talking about the lowest total cost of ownership. It's got low heat, low drift, high reliability, and best end of life economics with clean metallurgical recycling and a very strong IP position with a single global magnet-free patent family. So just in terms of thinking about stakeholders out there, what we've done here is just a little bit of a final thought relating to buying decisions, and we've broken it down into 4. And by aligning the motor's advantages with the priorities of investors owners on the one hand, which are entities that fund or own or control the SFSM intellectual property and earn through the licensing, royalties, and equity value. And from the perspective of motor producers and manufacturers that license the SFSM, design and adapt it to their factories, and supply SFM's sort of base motors into industrial and consumer markets. And for the operator, who are the companies that build products or systems containing motors, such as pumps, compressors, and appliances. Then, of course, finally, the customer, people and companies that purchase and operate the products that contain SFSM motors, benefiting from improved efficiency, performance, and operating cost reduction. And we think that this helps us to put, with a picture on a page, the measures that matter, because investors will be interested in downstream stakeholders. So essentially, here is a final summary that really looks at the direct benefits that there are for owning this global patent family, and that really speaks, I think, to the probability of adoption being so high, because if you look at the benefits, they really do extend right the way through from motor manufacturers to their clients and indeed the ultimate end customer. And just to conclude, we've pulled together this little quotation by Sir Henry Royce: "Take the best that exists and make it better, but when it does not exist, design it." Thank you very much for your time.